Hello, data and machine learning practitioners. I'm excited to welcome you on our webinar dedicated to the topic of data quality in the context of MLOps. This webinar is brought to you by Provectus, an AWS Premier consulting partner. A few notes before we begin. As we move forward through the content, you're very welcome to ask questions in the GoToWebinars questions tab. We'll address them during Q&A panel in the final part of our today's event. We'll share a webinar recording with you shortly after the event. To set your expectations, we will keep the level of details on 200 feet with the goal to provide you a strategy moving forward and continue our conversation in more details after the webinar. The objective of the session is to explore best practices of building and deploying reliable machine learning models, to review existing open source tools and reference architectures for implementation of data quality components as part of your MLOps pipelines. And finally, we encourage you to get qualified for Provectus Machine Learning Infrastructure Acceleration Program, a fully funded discovery workshop. Please stay with us till the end to learn more. Agenda-wise, we will start with introduction and setting up the context of this webinar. Then we will dive into common practical challenges and solutions for data testing and model testing. Then we'll discuss how MLOps meets data quality to wire all components together into a robust CI/CD pipeline. And at the end, we will tell you more about unique opportunity to join a machine learning infrastructure acceleration program by Provectus and AWS. Quick intro, I'm Stepan, a CTO and co-founder at Provectus. I'm in charge of technology, R&D, solutions architecture, and delivery. The topic of this webinar basically describes my background in data, machine learning, DevOps, and cloud software architectures. Rinat is a senior machine learning architect and practice leader in Provectus. He is an actual brain behind the content we'll be discussing today. Please do not hesitate to ask questions in the GoToWebinar questions tab as we move through the webinar content. And Rinat can assist me in answering those questions. And 90 seconds overview of Provectus. We are obsessed about generating value from data through artificial intelligence and deploying it to the real world. Provectus provides end-to-end solutions for businesses, and we consult executives, machine learning, and data engineering teams on best practices for foundational components like enterprise-grade data and machine learning platforms. Quick facts: we're headquartered in Silicon Valley, have more than 400 employees worldwide, and serve clients ranging from cutting-edge startups to large Fortune 500 enterprises. And what makes us different? We are an AWS Premier consulting partner specialized in machine learning. This is the highest tier for AWS partners. Some of our clients are listed here. We're comfortable working with big enterprises driving multi-million transformational projects, as well as helping startups, partnering with them from early stages through all the funding rounds and successful acquisitions or IPOs. So we have introduced ourselves. Can you tell us more about yourself so we can see who is in the room? It's a poll time. Let's have this. Let me launch the poll. I would appreciate your answers. Choose if you are data scientist, analyst, machine learning engineer, data engineer, QA specialist, or if you are in management role. That will help me to speak your language and tailor the content as we move forward. 5 more seconds to go. Appreciate your answers. All right, closing the poll. You can see the results now, I believe. So the majority of the audience is in data science and analytics. That's great, and I'm really excited to see a lot of people from the management. All right. Yeah, you can see the results now. Thanks. Let's start with the why question. I have borrowed this slide from the talk by Sanjay Krishnan and Gianna Wang from 2016. And the main point here that state-of-the-art competing algorithms compete for the accuracy improvements of a fraction of a percentage, and data cleansing and the proper data quality contributes 20x more into the final quality of the end-to-end solution. I believe it answers the question why you should invest into quality data for machine learning applications. Another real-world use case from Provectus client GoCheck Kids. GoCheck Kids is an amazing company that helps millions of kids to prevent vision impairment. Provectus and GoCheck Kids have been working on a problem of reducing manual overhead during child vision screening. Machine learning problem was framed as an end-to-end deep learning image classification models to detect child gaze, strabismus, crescent, and dark iris pupil population. We've been pushing the limits of deep learning modeling, trying to different data pre-processing strategies, feature generation backbones, transfer learning techniques, different objective functions to tackle dataset imbalance, and then finally identified issues with the data quality that impacted our results. After data cleansing and relabeling, we were able to break through the baseline algorithm and improve the final metrics by 3%. This is an excellent justification for investments into data quality. With this in mind, let's take a look at the typical machine learning workflow. Here is a simplified overview of the machine learning lifecycle that you all perfectly know. It has data preparation stage with ingestion, cleansing, merging, labeling steps. It produces a version dataset ready for machine learning engineering, where you do feature engineering, training the model, experimentation, and then finally select the model candidate to be promoted to operations. How do you think what stage of machine learning lifecycle requires quality assurance? Just think for a second and let's move forward. I believe the answer is quite obvious. Of course, all stages must be covered with data tests, code tests, and model tests. Data tests are essential since it is a part of the business logic. Data is a part of the business logic. Also, just a couple of weeks ago, researchers from Google has published a very relevant paper on data and error cascades in machine learning pipelines. The paper called "Everyone Wants to Do the Model Work, Not the Data Work: Data Cascades in High-Stake AI." Early error detection is very important. Even small unmanaged errors made on early stages of the workflow may lead to significant degradation of model performance in production. Metrics captured during model evaluation step measure not only the model algorithm in isolation, but the entire system, including data in its pre-processing. With this context and use cases in mind, let's dive into common practical challenges and solutions for data quality. So common challenge number one is in finding the right data to build machine learning model from. Quickly. Surprisingly, while investing into data warehouses, data lakes, data platforms, many organizations forget to think about step number 0 in machine learning experience after understanding the business problem, of course. Finding the reliable data source. To frame machine learning problem and architect the solution, you have to look at data, do an exploratory data analysis. And ironically, one of the most often issue is that people just start working with the wrong data. As we learned on the previous slide, having inconsistent, incomplete, or outdated dataset can lead into incorrect assumptions and problem framing on early stages. For example, if there is a dataset called user profile with 200 features uploaded to S3 location, there is no straightforward way to make sure this dataset represents the full population, to understand the full lineage and all transformations, aggregations, and filterings that has been made there, to understand who is an owner of this dataset, who is responsible for SLAs, versioning, and backward compatibility of this dataset. There's no way to make sure this dataset has passed quality checks, and so on and so on. With this context, let me ask you the second question and the last question, I believe. I'm curious to know how you find the right data in your organization to work with. Starting the poll, just a second. Launching poll. Yeah, let me choose this first option if you're just asking your team members where the data is, data analysts or product managers. Choose the second option if you have a comprehensive documentation in Wiki that everybody relies on. That's also a good option to have. Let us know if there is you just reverse engineer data pipelines and figure out everything by yourself. And it will be great to know if you're searching through the self-serve data catalog, so you're mature enough and see this entry point for all the data practitioners to work with. Closing the poll, 5 seconds. Closing the poll, sharing results. Great, thanks for your answers. Majority of the audience is asking team members, which is good. The communication sometimes, and good communication can solve process inconsistencies and tools immaturity. That's great. Many people reverse engineer data pipelines, and yeah, I'm glad to have people who are mature to have a data catalog, which help them to find the right data sources self-serve. Great. The solution of this problem starts from the management aspect. Let me share a couple of strategic advices to be discussed with the leadership team. As you may know, a lot of problems are not in technology and tools, but rather than on an organizational and management levels. Monolithic data lakes and data warehouses have two major challenges that impact quality of data. First one is lack of domain context in centralized data engineering teams. Usually very specialized team of data engineers that ETL data from multiple sources to data lake is in charge of all data pipelines and all validations for all products. Obviously, you cannot test the data if you do not understand it. Second thing is lack of ownership and product thinking of data. What will happen with the data pipelines if web engineer will change the column type from number to string? Web developers may not even know that RDS transactions and clickstream events are being used for critical real-time decisions by sales and marketing teams. So, and data mesh is the convergence of distributed domain-driven architecture, self-serve platform design, and product thinking of data. It brings data closer to domain context Basically, it recommends putting data engineers into product teams. And we also recommend putting machine learning engineers there as well. So the data and data pipelines are now being owned by domain experts. Also, it introduces the concept of data as product and all appropriate data contracts. The same way product teams design, version, and take care about REST APIs, they become fully responsible for making data valid, consistent, and up-to-date. For more information, I encourage you to read a correspondent article by ThoughtWorks, and we're happy to share our experience and implementation of the data mesh concept. The second strategic advice is to invest into the global data catalog of catalogs. An entry point for all product managers, data engineers, machine learning engineers. It is a missing piece in most of the reference architectures, and there is no established leader in the market. Modern data catalogs should support end-to-end lineage from raw data to machine learning models, and they should provide quality metadata for each data set so users can rely on it. I'm not listing proprietary data catalogs here, since I strongly believe that enterprise data and metadata cannot be logged in any proprietary service and should be exposed openly but securely to other systems and users. Would be happy to provide more guidance on data catalogs as we move forward. The second challenge is how to get hands-on. What exactly to test, how to test, and who should test data in machine learning models. Since there are no people with title machine learning or data QA. So even the companies understand the importance of this topic, it's quite challenging to get started. And as a result, low productivity of machine learning engineers having to deal with data quality issues on a daily basis. Here is how you can get started. For those who've been working with data for a while, default data quality checks are not new. Data analysts, before building report, they validate data for duplicates, for missing values, for format errors, for different types of integrity. The only issue is that most of that work is one-off scripts in notebooks or SQL clients. A bunch of SQL scripts is hard to manage, support, and operationalize. How would you programmatically scale your data validations if data is spanned across Apache Kafka, Apache Spark processing, data lake, and then ends up in Snowflake, RDS, and machine learning pipeline? There's no way to reuse and maintain even these default quality rules as SQL scripts for all those systems holistically. More advanced methods for data validations include tests for data distributions. For example, you would like to make sure that the distributions of your training data set matches distribution of your production data. Kolmogorov-Smirnov tests, as well as chi-square test for categorical features. AutoML is being used to automatically choose the best outlier detection algorithm for particular data type and the use case. And heuristics-based automatic constraints generation and data profiling for complex dependencies is something that is in early R&D stage in the community. Our recommendation is to start with basics and then explore more advanced methods. If you sort out data ownership issue, introduce data as a product best practice, implement the most common data quality checks, versioning, and SLAs, it is going to be a huge win. A best practice for the companies to minimize the upfront investment into manual implementation of data quality assertions. There is a problem that, like, writing even simple validation rules is tedious, time-consuming, and error-prone, especially when it's done from scratch. The required efforts are multiplied if your datasets are extensively used, but the documentation is poor, or if schema is being involved all the time. It is recommended to utilize unsupervised approach that can be summarized as depicted here on the screen. So you can run so-called data profiles that produces summaries per column. The tools can use those summaries to generate suggestions for data check. For example, if there's a numeric values distinguished as text, if there are no null values, all the values fall into the same range, and so on and so on. Optionally, these generated constraints can be evaluated through the holdout subset of data. After all these steps are automated by the tool, data engineer can review, adjust, accept, or decline these checks and include them into the test suite. It is worth mentioning that this type of tooling is still in early days. There is an active development of new kind of profilers and constraint suggestion algorithms. Tools-wise, there are just a couple of options. Yeah, this field is pretty wild at this moment. Deku is an open source library for Apache Spark that allows you to profile datasets and enforce your own constraints system. Great Expectations is, in our opinion, a leader in terms of maturity, developer experience, community support, and adoption. It allows you to establish data contract and generate data quality reports. Great Expectations is a lightweight and not opinionated. Can be integrated into machine learning pipelines, CI/CD pipelines, and other routines. Expectation is a declarative assertion about expected format, content, or behavior of your data. It works with Pandas, Spark data frames, Redshift, Snowflake, BigQuery, and other dependencies out of the box. And the beauty of Great Expectations is in decoupling of rules engine from actual backend. You can maintain rules in one place and then apply it to different parts of your data pipeline. It greatly reduces total cost of ownership for data QA. Yeah, and TensorFlow data validation and DBT is more niche products that I'm not going to describe in details. All right, so we have briefly covered data QA. Let's move to the model testing. On a high level, you can treat model as a black box application you feed with test datasets and analyze output datasets. You know, in model development routine, there are train, test, and validation datasets. In a real world, there are many validation datasets, and it is a separate workflow for managing datasets for quality assurance for machine learning model. For traditional QA engineers, there is an analogy. Each row in a dataset is a test case, and dataset itself is a test suite. For example, there are golden datasets used for user acceptance testing, security datasets with adversarial inputs, production traffic replay, regression datasets, bias, and edge case datasets. So that's a whole bunch of different datasets you run your model through during this delivery pipeline. And again, you need to make sure that datasets used for model testing are tested by themselves. There is a duality of model testing. By testing a model, you test datasets this model has been built from. For example, model bias. Is it an algorithmic bias or dataset bias? Usually you have to check both. Let's spend a minute on testing for bias. Bias is considered as a disproportionate inclination for or against an idea or thing. And there are more than 10 different types of bias. For example, selection bias, when you train data set, does not represent the actual population. Systematic bias, when have consistent deviation and repeatable error. There are cases when there is a bias for or against an outlier of filtered data. Also, model could be biased towards default values used for replacing missing values. As you may guess, many of those bias types could be prevented by data QA and specific data validation rules that we have discussed before. Other bias types, for instance, like bias variance trade-off, can be only detected by analyzing training metrics and metadata. There are more complex bias issues caused by personal perception of data scientists and framing effects of annotation questions. This is usually solved by analysts and subject matter experts manually. We don't have time to dive into the model testing best practices for security, but I would be happy to follow up on this topic after this webinar, because by itself it's a 1-hour talk. This is a summary of tools to be considered for model testing. Clever Hands by Ian Goodfellow and Nicholas Papernot. You know them. Adversarial Toolbox for model robustness by DARPA. For bias and fairness, I would highlight AI for Fairness 360 by IBM, original open source by IBM. It's a toolbox with different bias detection algorithms. It is worth mentioning that most of these tools are mostly used by researchers on MNIST datasets, and there is very limited adoption and production for real applications at this moment. SageMaker Clarify is the first fully featured service that could be used by developers. Remember, bias and fairness are a complex R&D problem that could not be solved overnight. And it's strongly recommended to offload to fully managed service like SageMaker Clarify, of course, knowing its limitations and points to be extended. So usually it's a combination of the in-house made checks and algorithms, open source algorithms, and fully managed services like SageMaker Clarify. Okay, we have discussed the tools and best practices for model and data testing. Let's see how it converges into end-to-end machine learning platform. Let me remind you what is the core of MLOps. So we have 4 inputs: the code of ML model, the code that describes machine learning pipeline steps, the code that describes your infrastructure and dependencies. Obviously, any code is to be stored and versioned in Git. You have also fixed, immutable, and versioned dataset as an input for your machine learning pipeline. A dataset is usually generated from the centralized feature store. You can think about ML Orchestrator as a meta compiler that takes all these 4 inputs and compiles it into the model. As any compiler, it outputs logs, metrics, and alerts, as well as tons of metadata to be stored and analyzed. As we have learned, it is required to embed data quality gates on every step of my ML pipeline. It starts from monitoring and checkpointing features in feature store, validating training dataset, then analyzing model training metrics, and then finally monitoring actual predictions in production. Zooming into the validation pipelines, data validation jobs could be deployed as a separate process that periodically scans feature store, or it could be an actual part of the Kubeflow pipeline. Great expectations for Kubeflow is a recommended way to give the tool for data QA for everyday developer. There is no officially supported Great Expectations operator for Kubeflow, but stay tuned and collaborate with community and Provectus. You're going to see some great things very soon. We also recommend using various components of SageMaker platform that are fully serverless. For example, SageMaker processing and training jobs can be used to offload heavy workloads related to data preparation, validation, and quality checks. For instance, Great Expectations can use Spark backend, and on itself, it could be launched as a part of SageMaker processing job with serverless Spark integration, which is quite cool. You don't need to manage an EMR cluster. You just run it and forget. There are ready-to-use pre-built images for popular frameworks like Spark, and you can also bring your own container with other libraries like the ones that we have previously mentioned. Processing job contract is quite flexible, and it enables the convenient ways to scale, manage, and monitor workloads. SageMaker Clarify can be used to generate bias and model explainability reports and have them as quality gates for your pipeline. SageMaker Model Monitor works with model endpoints, and production data capture becomes a matter of configuration of your SageMaker endpoint. And then you can use it to enable data quality checks, model quality checks, and bias detector, or even like feature attribution drifts on the actual production data. For many of these tasks, you can use the platform tools like SageMaker Clarify or pre-built DQ container. But there are also options to bring your own custom monitoring algorithms. Let me summarize our recommendations and takeaways in 3 bullet points. You can deploy machine learning model. You cannot deploy machine learning models to production without clear data QA strategy in place. As a leader, we recommend focusing on organizing data teams around product features to make them fully responsible for data as a product. Remember, a lot of problems could be fixed on management and cultural levels. Design data QA components as an essential part of your MLOps foundation. It could not be done in isolation by separate QA department. And traditional QA engineers are not skilled and are not hands-on with machine learning workloads. All right, hope you have a solid strategy for moving forward with the data and machine learning infrastructure. Here is the next step for you to get started. Provectus and AWS have jointly developed a machine learning infrastructure acceleration program. It is designed to help businesses build a robust machine learning infrastructure to accelerate AI adoption enterprise-wide. In a nutshell, it is a combination of pre-built quick starts, reference architectures, in-person workshops, and funding programs. Provectus and AWS will work with your leadership team to align your company towards the North Star architecture, processes, and machine MLOps culture, so we can tap into benefits we have highlighted during this webinar faster and with less upfront investments. The offering is available for a limited number of customers and is fully funded engagement. Please dedicate your time, not money, share with us your boldest goals. Apply now so we can help you to get qualified for the program. The engagement starts with 3 days virtual discovery workshop with clear deliverables. Deliverables include an end-to-end solution architecture tailored for your use cases and requirements. An adoption roadmap is something that will help you to get from point A to point B in the long term. Total cost of ownership will help you to not only to plan your budget properly, but also allow us to tap into different funding opportunities for further phases. Since the workshop is fully funded, we also expect a certain level of commitment from executive sponsors and dedication from the customers in management and technical teams. After the workshop, we usually move to very quick iteration, basically one sprint from start to finish to get your first machine learning pipeline covered with data and model quality test deployed on new infrastructure. Then we help you to scale and manage machine learning infrastructure for other use cases in your enterprise. Please use the link in a GoToWebinar chat window to apply for the acceleration program. It will also be sent to you in a follow-up email with a webinar recording, so you will not miss it. We are recruiting only 10 customers to qualify for fully funded engagement. Happy to answer questions. Hopefully you like the content. Let me take a look at the questions tab and see what you have. Oh, quite a few questions. Yeah. Yeah, will you share the decks and the video? Of course, yes. We will send all the materials right after the webinar. Yeah, same question from Money. Okay. Yeah, and okay, just a long question from Glenn. Let me take a pause and read it so I can understand. Okay, the question from Glenn is, the 2020 data is anomalous due to pandemic in that sense. So for instance, sales data, product data could not be used for the new machine learning models to be built. Is there special advice or guidance on how to accommodate that the most recent data has an asterisk? Yeah, that's a great question. This is obviously very specific to the domain and to the data, especially with the sales and there is a new normal, as you all know. You still can learn from the historical data. You still can use it for machine learning modeling with some asterisks, as you mentioned. For instance, the baseline. And you see the history repeats and the user behaviors, yes, they change, they drift. You can retrain on the latest data sets, and you can constantly retrain on those latest data sets. However, the historical baseline is quite important, so it can you can use it. So it's not the it's more a question of machine learning modeling and not a data QA per se. I wouldn't recommend just forgetting about the data that has been gathered before 2020. So the data by itself might be relevant, but you may not trust it because of certain circumstances. Okay. Okay. One question from Glenn. I will try to skip it, and then if we have time, answer it at the end, because it's a question from Elaine. Selection criteria regarding funded approach. I can elaborate on that selection criteria. The main thing is commitment and sponsorship from the customer. So as any fully funded initiative, it is not something that is nice to have. If we see that you have a real pain point, you have it on your roadmap, and there is a real support and sponsorship from the management, this is the main criteria to be for the approval. And of course, timing. So if there are just 10 slots available. Question from Sri. Could you elaborate on the idea of data as a product? What does it mean to design data team around a product? Big question. Thanks for asking. Let me reiterate. Let me scroll to this slide to give you better. Yeah, this one. So let's reiterate the problem first. In many org structures, there is a specialized data engineering team that is the only job they have is to write data pipelines from point A to point B. For all data is being ingested, processed by this data team. The challenge is that it very often, and this team does not understand the business context. The data are just bytes, and they follow the requirements from and specifications how to transform that data. Obviously, if you do not understand the business context, you cannot develop the solid validation pipelines and assertions of the data. If you bring the data engineers closer to the domain context, and the team which has the full context about the domain is the product team that builds a particular feature. You know all ins and outs. You know how this feature is going to be presented to the end user. You know all the user stories and so on and so on. In that case, that becomes much easier for data engineer to build the quality data pipelines. That's the first thing. And also, when the data team makes the data, product team makes the data exposed to the other teams, it treats as it's the same way as REST APIs or web application they build. They apply all the best practices, versioning, backward compatibility, and they basically own this, because the issue of the ownership, when the data is just bytes and columns and rows in your database, nobody owns this from the product perspective, and that's an issue. Nobody takes care about the migration. Nobody takes care about the documentation, and so on and so forth. And this concept, it really makes product teams to think about data as part of their product and not something secondary. Hopefully it explains the idea. Of course, the implementation wise, there are so many things to talk about. So many questions. I'm so excited. Question from her. Could you elaborate on having dedicated pipelines to check quality versus having data quality gates within model-related pipelines? It's a good question. But it is not one versus another. Both approaches are pretty valid. When you have non-blocking quality check, you just, for instance, you have infinity data stream, or but just in your data lake, and data incrementally is being ingested there. You periodically check this. You may have some validations being made at ingestion time, and some other validations more complex when you need to count things, when you need to profile, when you need to figure out some more complex integrity checks. It could be done separately in the background with checkpoints. So you run the bad job, you analyze a partition of your data, and you produce the quality reports. And this is a totally separate pipeline. If you another use case, when you sampled and generated your training data set, and you're about to start your model training pipeline, that makes sense to run the to have a data quality step as part of your machine learning pipeline, so we can you can make a decision, go and no-go decision as a result of this quality check. Another use case, when you analyze the production inferencing data, so you're analyzing it, matching it against your training data, and you look for data drift and concept drifts. Obviously, this is by design, this is a background process. Okay, hopefully it answers your question. Question from Money. If you find unexpected bias in your model result, how would you deal with that? The question is pretty wide. Of course, it depends on the type of the bias. Of course, it depends on a model. And yes, of course, if it's a data bias, of course you have to understand the root cause. If is it the loss function, is it the input data set? The easiest way is to fix the data set, and you go and fix the data set and make it not biased, and also you check the distribution of your data set if it matches the production population, the actual population. So again, no, there is no straightforward answer. This will require your expertise and basically machine learning engineer. If he discovers the bias, he knows what to do. That's his expertise. Moving forward, in favor, let me do a quick time check. Okay, I'm glad we have some time left for questions. In favor of open source data catalogs, could providers data catalogs such as Glue or Glue data catalog usually provide built-in collections for their platform as a service data storage statistics? What about the overhead of using a third-party data catalog? Good question. I can talk about that for an hour. Yeah, first of all, Glue is not I would say a data catalog. Glue is more a metadata store, and the only metadata it provides is about the a schema and tables that you have. It does not have, it's not quite user-friendly. You cannot give it to product manager. You cannot easily search there. That's a limitation. Google Data Catalog is more higher level tool. Yes, of course, they have built-in connectors to cloud-hosted data storages like Redshift, BigQuery, RDS, and others. And the issue is that in most of the enterprises, modern enterprises, you have data here and there. You have some data in raw format, some data is on-premise, some data is in a cloud, in another cloud, and you need more holistic view of that. Also, those catalogs, they do not support machine learning models and machine learning pipelines as assets, as entities. So you can you're losing this end-to-end lineage and end-to-end discovery in that sense. What about the overhead of using third-party data catalog? I would say overhead, of course, you need to be cautious. The first thing that you need to make sure that data catalog does not lock your metadata, because when you scrape or when you consume the data, the metadata about your data from the data sources, you need a way to pull to discover that and need a way to expose it to other tools, not only to the proprietary data catalog that you have installed. That's the main issue. That's the main overhead, I would say, for having that. And of course, security. Many of the modern legacy data catalogs, they need access to your data. So you expose entire data warehouse to your data catalog provider, which is not secure enough. And this is and the modern design is quite different. The data catalog should provide the metadata. The data sources should provide the metadata, and do not allow data catalogs to get the access to the actual data in that sense. This is like a bit more complex architecture, but this is I think should be favorable in terms of the security. Okay. Question from Zahari. I'm sorry, I'm skipping some questions because there are so many of them. I would be happy to follow up on any unanswered questions or the questions that require more detailed discussion. There are many open source tools for MLOps, ranging from those that do very specific steps to those providing an entire ML pipeline. How do you narrow down or choose what tools to use? Do you recommend broad tools that do many steps, like TensorFlow Extended or Kubeflow, or several individual tools that you can tie together? A great question. In general, the composability is the principle number one of all the modern architectures. You cannot have a silver bullet and have it to handle everything for yourself. if you're a techie enterprise, if you're a technology company, it's better to look for the tools that not opinionated on a platform they run, on a steps you can extend, on a libraries you can bring, on a images you can use, etc., etc. So that's a number one principle. I think I had this a very solid webinar on Kubeflow and SageMaker and the benefits of using of marrying two worlds, open source and fully managed AWS services. It's better to follow to this webinar, so we discuss pros and cons and all the benefits of this approach. I would be happy to follow up on this as well. Okay, one more question. Another question about the slides, of course. Yes, we're gonna. Okay, the question, can you show the QR code for the workshop? That's an easy question. Let me. Oh, here it is. Okay, one more question then. Okay, Glenn, that's you're asking there. Glenn is asking quite deep questions. I appreciate that. I would think about this and just follow up with you. Maybe would be happy to follow up or chat in Slack. Basically, that's a good segue and maybe the final note. You should receive the invitation, just a Slack URL to the Slack workspace when we can follow up and just have more thoughtful discussion there. I believe it's in a chat window, if I'm not mistaken. Yes, there is. Here it is. So we'll review all the questions and those that are not answered or not fully answered, and we'll try to follow up afterwards. Thank you so much. It's quite engaging. So many questions, and yeah, happy this topic has resonated with your roadmap and resonated with your pain points. Thank you so much, and have a great rest of the week. Okay. How can I finish this presentation?